Good morning, students. Welcome back to your another class of mathematics with the same topic of compound angles. I hope all of you have learned the formulas I've told you and definitely practice the problems I have given to you in the last class. Okay, so moving forward with the same topic, I have chosen certain problems for you and I will be solving them one by one. So let's start the class. So the first problem, all of you can see here, it's a small problem of 2 marks. Every time I do a problem, I will tell you that the particular problem can come in your examination for how much marks. This will help you to practice. Okay, students. So this is the one I have written. Let's read the problem. If cos 8 degree minus sin 8 degree by cos 8 degree plus sin 8 degree is tan theta. So you can see this entire expression is written in terms of tan theta. And I'm here asked about the value of this theta angle. Look children, this is a very important problem. The process I'm going to do here is not only required for this particular problem, but also it is utilized later on in many other problems. So let's begin. Okay, now here, what the tactics I can do here is the formula for the compound angle for tan. Do we remember that? Yes, I hope we all remember that. That is tan of A plus B or tan of A minus B. Okay, so what was that? See, here in the numerator we can see a minus sign and the denominator we can see a plus sign. And nothing here is in terms of tan. So let's convert it into the value of tan by the method we have to apply in class 10. And I hope all of you remember this one. Dividing the numerator and the denominator by cos of 8 degree. Because sine by cos is going to make a tan. So dividing by cos of 8 degree to the numerator and the denominator. Let's see what happens. So 1 minus tan of 8 degree and this is 1 plus tan of 8 degree. Correct children? Now 1 is written by tan 45 also. Isn't it? We all know that tan 45 is 1. Am I clear? So let us write down here tan 45 instead of 1. So what it is going to make now? Now look children, I am not going to write here as tan 45. I will be writing here. See, I hope all of you understand this one. I am multiplying tan 8 degree with a 1. We can do that. And in the place of 1, I am placing a tan 45. So again I am going through the steps. This was the thing. And I have put here tan 45. Again here tan 45. Now let us recall tan A minus B. Tan A minus tan B by 1 plus tan A tan B. Okay, so see how I'm reading it once with this expression. Tan A, that is tan 45 minus tan 8 by 1 plus tan A tan B tan 8 tan 45. What does it make? It is making tan of A minus B. So let's take this one A and this is B. So A minus B, that is 45 minus 8. It is giving me how much? Yes, that is 37. So I hope we have reached the answer that this is going to be tan 37. And how am I getting? By 45 minus 8. The formula I used here, must write down the formula. It will help you to recall and definitely you will never make a mistake. Okay, so this is the first problem for you. We will be going to the second problem. Here is the next problem. Okay, let's read that. If tan A is equals to x tan B, we need to prove here sine of a minus b by sine of a plus b is equals to x minus 1 by x plus 1. Okay, so let us go through the problems one more. We have a given part, all if you can see that, and this is the one to be proved, and the proof part doesn't contain, first of all, any tan, correct? Secondly, point to be noted, a and b is now in the form of compound angles. Okay, so how to do that? Please look at the right hand side of the problem to be proved. It is x minus 1 by x plus 1. So, where that x minus 1 and x plus 1 can be brought with the help of componendo dividendo. As I told you that I will tell you every time the marks which may be allotted for a given problem. So here this kind of problem can come for 4 marks. Okay, so let's begin the problem. Here componendo and dividendo I will be using, but first I have to rewrite the given part in a suitable way. See what I have written. See, I have written tan A by tan B as x by 1. Now, we can see here we have x minus 1 in the numerator and x plus 1 in the denominator. But everything it is in sign. So, let's first convert this tan and tan B into sine and cos. So, after converting this tan and tan B into sine and cos, I am going to write down the expression as, I am erasing it, sine A cos B sine B cos A. What I did, I have converted the tan into sine and cos. Let's apply componendo and dividendo. So by componendo and dividendo, I am going to write down the entire expression as this numerator minus this denominator by this numerator plus the denominator. I hope all of you have applied this one, so I may not need to make you this one clear. Correct. So let's write that. So by C and D. See this one. In short, we can write down the component of dividend like this. So I'm writing here sine A cos B minus sine B cos A, and the denominator sine A cos B plus sine B cos A. But this is only the left hand side part. Let us write down the right hand side part, which was x by 1. Now it is the required one. That is, we reached almost the required proof, x minus 1 by x plus 1. So see this one, sine A cos B minus sine B cos A, and sine A cos B plus sine B cos A. And I hope all of you are telling in mind that this is the formula of sine A minus B. This is the formula of sine A plus B. So we reached the answer. Just one more line, that is sine of E minus B and sine of A plus B, giving me the required expression, and it is hence proved. Okay, so this is where I have applied this important ratio and proportion concept by componendo and dividendo. So after this, let's move to the third problem. Students, now the another topic I have chosen for you is a maximum and minimum value of the particular trigonometric expression you can see in front of you. That is a cos theta plus b sin theta. Let us see how to find out the maximum and the minimum value of the particular thing. Now again, let me clear you one thing. This particular expression I'm going to turn either in terms of cos or in terms of sine. Fine. And we know the range of sine theta, that is from -1 to +1, and even of the cos theta. That is the only concept we are going to use here. Another one more thing, this is a very important problem, not only for your class 11, later in class 12 also you will be continuing with the same techniques I'm going to use to convert this particular trigonometric expression into a one single expression of either sine or cos. So let's see that. So here you can see I have taken something which is arbitrary. I have not taken any like constant value. You may get the problem in some another way. Now look this one very carefully. Here we have some constant a cos theta, some constant b, and a sine theta. Let us take right angle triangle and an angle alpha here. So can I take this one, say r. R is another constant, and I am going to take the perpendicular as A and the base as B. See children, the reverse thing can even be taken. I am not pressuring you off to take that. Suppose I want to convert the entire expression in terms of sine. So in terms of sine, let's recall the formula of sine A plus B. Sine A cos B plus cos A sine B. So here it is cos theta. I want to make it in terms of sine alpha. And this one I want to make a cos alpha. So the expression will become sine alpha cos theta cos alpha sine theta. So this is going to give me a expression only in terms of sine. So for that I have taken a use of right angle triangle and the simple trigonometry technique we have used in class 10. So this is not new to all of you. Okay, so we all know perpendicular by hypotenuse and the base by hypotenuse. So see children, sine alpha and cos alpha is now defined in front of you. So I'm going to write down this A as r sine alpha and B as r cos alpha. Understood? So this is what? Tell me. Yes, hypotenuse. What is the formula for hypotenuse? Root over of a square plus b square. Okay. So after substituting this thing, so what the entire expression is going to look like? R sine alpha plus, not plus, cos theta plus r cos alpha. Now read as a whole. R, take common. R, if it is common. Now read this as a formula. Sin A cos B cos A sin B. So the entire expression is now in terms of sine. Students, if you want, you can convert the same in terms of cos. And how can you do that? You have to make it a r cos alpha. And you have to make it r sin alpha. That's why I was telling you, it's up to you. It's your choice what you are going to take it. Understood? Now, this a cos theta plus b sin theta expression is now in terms of this. And what is r? It is defined like this. root over of a square plus b square. Now how to find out the maximum and the minimum value, which was my earlier problem. So let's see that. So now let's recall what is the minimum and the maximum value of sine theta. That is from -1 to +1. So I'm going to write the same. This particular sine of alpha plus theta, this particular sine of alpha plus theta is greater than equals to -1 and less than equals to +1. Always sine of any angle, it will be within the range -1 to +1. Now, do I have the only sine? No, we have the expression as r sine alpha plus theta. So let's throughout multiply by r and r and r. So what I did, I have multiplied throughout with a value of r. Now let's see what happens. I'm rubbing, let me erase the previous part. So the one I was telling that after multiplying with r, we are going to obtain an expression like this. So the value of the main expression, which was converted in terms of sine only, that is r into sine of theta plus alpha, is now ranged between -r to +r. Now what is r? We have already found the value of r, so let's substitute that one. So this is, see what I am going to write. See what I have written here, minus root over of a square plus b square, because it is the value of r, and here also plus root over of a square plus b square, this is the value of r, and this is the required expression whose maximum and the minimum value was asked to me. So the minimum value, all of you can answer, this is this minus of root over of a square plus b square, and the maximum value is this one. Now students, if you have some values here, say for example if it is 7 and if it is going to be 24, correct? Suppose some values of a and b is given to you. So what are you going to do? This is going to be say 7 and this is 24. You will first calculate the value of root over of a square plus b square, and I am going to get here 25. Okay, so that is 7 square plus, this is 49 plus 576 root over, that is going to give me 625. Already you know the Pythagorean triplet here. So let's write down. The minimum value in that case will be, and the maximum value is going to be. So I hope you understood this particular part, how to find out the minimum and maximum value of the entire expression. With any such values of AB, you will be able to find out. Okay students, so that's all for today. I hope you will carry on with the particular compound angles, practice well. I will be back with you with the second part, that is transformation formula, in your next class. That's all for today. Have a good day.